Good evening, ladies and gentlemen. I would like to introduce you a paper about the empirical relationship of humus formation in soils in the arid zone of Kazakhstan. This paper was done by Professor Khozhanov, Professor Tursunbaev, Professor Masatbayev, and Mr. Nurabayev, and the Professor Assis. The first authors are from Dulati, MKH Dulati Taras Regional University in Kazakhstan, and me as a professor for Federal University of Ouro Preto. And I would like to show before a summary of the presentation. Firstly, I would like to show the general introduction. Afterwards, objectives, review. The fourth point will be methodology, results and discussion, conclusions and acknowledgements. As introduction, we have performed analytical work, firstly to determine the relationship between the natural characteristics and level of humidification of the soil, MP. Of course, the rational use of agronomic practice and predict biological yields of crops, the level humus in vivo, depends upon in agriculture from main parameters which have a direct impact on the productivity of agricultural crops. Currently, under the influence of anthropogenic activity, there have been transformations of natural processes in a natural object due to the use of material and energy resources. In agricultural landscapes, the change in energy du as a function of the time dt can only be due to the exchange of energy with the environment through heat exchange and processes related to the performance of work dW and metabolism d2. These photos shows where the research was done in Kazakhstan, the arid zone of Kazakhstan. And during a partial time that I have been in Kazakhstan, we have discussed with many students and professors. This photo shows exactly this discussion that I have done with the Professor Khozhanov and Professor Tursunbaev. That's the both in front of me here. And I have discussed about these technological aspects, considering not only the problem concerning the paper. The objectives from this paper in 2017, there is in the head of state of the people of the Republic of Kazakhstan, dated 31st January 2017, the third modernization of Kazakhstan global competitiveness for 5 years. In this document, there are many points that were written. The first one, increase in the area of irrigated land by 40%. Additional area of 2 million hectares based on this irrigation. Implementation of the priority direction by diversifying the agribusiness. And development of an efficient system of storage, transportation, and marketing of goods. And of course, by this year, 2021, increase on food products export by 40%. We have done a review in the literature, and now I would like to show some points discussed in this review. Firstly, the productivity of the agricultural landscape was done by Pegov and Komyakov, 1981, is estimated as follows. P is equal S multiplied by CL for natural synosis. And P is S multiplied by ART multiplied by GGT, where P is the potential productivity in tons per hectare, S is soil index, CL is coefficient of climate favorability, ART indicator of compliance under climatic conditions with a given crop. And GGT coefficient depending on the production culture. By this review, by using the same consideration of Professor Pegov and Komiakov 1981, when increasing the production potential, it is very important to know the dynamics of accumulation of or depletion of humus reserves in the soil. Firstly, the change in humus reserves can be approximately described by the differential equation, as you can see below. This was done by Golovanov, 2008. dG divided by dt is equal A minus B G multiplied by T divided by, that means, this one means the differential productivity time hectares multiplied by year. G is A divided by B plus G0 minus A divided by B multiplied by exponential by minus B multiplied by T. This equation was done after the integration of the first one. G0 is the current humus reserves in tons per hectare. A is the formation of new humus due to the humidification of plant residues. GRAST, organic fertilizers, GORG, including siderites, as well as the loss of humus as descending moisture contents, GPHIZ, in tons per hectare. B is the coefficient that takes into account the loss of humus, year to -1, and T time in year. The formation of new humus is estimated according to the dependence. A is GAST plus GORG plus GPIZ PHIZ set. To calculate the intake of humus during the humidification organic residues, you can use the formula Vasiliev 19084. GRAST is P multiplied by K index K multiplied by K index G. P is the yield of agricultural crops, tons per hectare. KK is the coefficient of yield of root residues, dry matter. Kg is the coefficient of humidification of dry matter. The values of Kk and Kj coefficient are given in table 1, as you can see in this figure. That means the value of Kk and Kg coefficient done by Vasiliev 1988 is done in 3 columns. The first column is written culture, and the second one is organic matter yield, and the third one is coefficient of humidification. That means the culture you can have 1 year perennial grasses for hectare per year. We have this organic matter yield is 0.6, and the coefficient of humidification 0.2. In the second line, you have 1 year perennial grasses for hectare per year. We have for the first one 0.15, and for the second one is 0.2. For perennial grasses 2 and 3 years for hectare per year, we have the first one 1.2, for second one is 0.2. Perennial grasses 2 and 3 years for green fodder is 0.3 for the first one, is 0.2 for the second one. Annual herbs in hectare per year, we have 0.4 for the first and 0.2 for the second. Annual herbs for green food, we have 0.4 for the first and 0.2 for the second. Cereals and legumes, 0.8 for the first and 0.2 for the second. And potatoes, roots, we have the 0.1 for the first and 0.1 for the second. And corn for silage, 0.07 for organic matter yield, and for coefficient of humidification, we have 0.2. We have now shown here these 4 pictures taken direct in the field where the research was done. We have four photos where you can see exactly the humidification and the culture of some vegetables. Based on the estimation of the amount of humus that comes in the composition of organic fertilizers, is carried out using the iso-humus coefficient, which determines the amount of stable humus formed from 1 kg in terms of dry matter, of organic matter or organic fertilizer introduced in the soil. Lose, Mathieu, 1998. Gorg is K index IZ multiplied by D, where the first one, K IZ, is the iso-humus coefficient, and D is the dose of organic fertilizer, tons per hectare of dry matter. From this one, from the analysis of the above materials, it becomes clear that under the influence of vegetation, the number and composition of microorganisms changes, and consequently, the intensity of the process in which they participate. Such changes, which are the result of interaction of plants and microorganisms, determine the degree of development and nutrition of agricultural crops. In this regard, there is a need to study the microflora of the rhizosphere to develop techniques that favorably affect its development and composition to improve plant nutrition and obtain, of course, high yields, taking into account the energy resource of a particular area. The methods, that means based on the long-term field studies for the period 1984-2016 in the Southern Area C region, Professor Khozhanov identified, first, the structure of the formation of the natural environment. Second, the level of soil humus formation M index R, which shows that the maximum number of factors affecting the soil formation process are concentrating at the level of landscape provinces and geographical areas, is described by the following expression. That means this equation shows exactly many factors that affect the soil humus formation level. That means we have RL, this radiation balance, value of level location. Beta is share of groundwater salinity. S index N, indicator of soil salinity. TB is the temperature of the air. WB, humidity of the air. V is the wind speed. O index S, precipitation. C, the share of irrigation water salinity. GR, the level of groundwater. And mu is the coefficient taken into account the use of agricultural practice and farming system. That means using all of these parameters based on the equation proposed by Professor Khozhanov, we can have the level of soil humus formation based on the equation above. Based on the method, solar radiation is actively involved in the process of humus formation, R, latitude, delta, and elevation, H, and air temperature in the period above, 10 degrees, with empirical relationship of the radiation balance, R, with the sum of temperature above 10 degrees. That means we have divided all of the areas based on literature and our research. Firstly, for areas of excessive moisture, Masatbayev et al. In 1969 results in the following formula. R is the constant 0.01042 more than degrees Celsius plus 8.52. For the Urals, G.V. Belonenko, 1969, R is 0.01 more than 10 degrees Celsius plus 7. For Belarus, MG Golchenko 9071, R is 0.0093 for more 10 degrees plus 10.8. For the arid zone of Russia and Central Asia, we have U Nikolsky and Shabanov 986, R is 13.39 plus 0.079 or plus 10 degrees. For the southeast of Western Siberia, Doroshenko 971, he wrote that R is 2.25 to plus 0.60 or plus 20.4. Semi-empirical relations of the radiation valence are with latitude and elevation H for the CIS station. Brachenko 96.7, he proposed that R is 88.3 minus 1.06 multiplied by this. Latitude minus 0.0324, H0 is the height. 8 plus 0.15 alpha, where alpha is the duration of the sunshine for May to August as a percentage of the possible. By using all of this data and the experiment that has been done in the Kazakhstan, we got some results that I would like to comment now. For the natural system of Kazakhstan, the indicators of the radiation valence depending on the absolute height of the terrain, H, were not previously considered. Therefore, we try to define this gap in science and clarify the actual energy indicators, taking into account the geography of the area. That means for the southern region of Kazakhstan, R is LO index C multiplied by 1000 minus H divided by 200. The proposed equation will represent the actual geographical state of the particular region. It clearly expresses the indicators of latent heat of vaporization, L, elevation, H, and precipitation, O index S, which variable reflects the actual values of the radiation valence. The study of the thermal valence of the irrigated zone allowed us to establish a relationship between the radiation valence, R, and the evaporation rate, E index 0, which is correlated by the PDS. R is equal, bracket, E0 plus 800, close brackets, divided by 10. That means for the middle and lower reaches of the Amu Darya and Sir Darya rivers, the correlation between relative air humidity, W index B, and evaporation is described by the equation E index 0 is equal 1000 multiplied by square of L divided by W B index B. That means the reference of radiation valence to the absolute height of the terrain in the arid zone of Central Asia and Kazakhstan is on the order of 0.61 and 28.96, and it can be expressed as, firstly, Rn is R divided by hand. Describe it as indicator of the radiation index per unit of absolute altitude of the terrain. Hence, it can be seen that with the same primary climate zone, the pointers Rn are not the same. This gives reason to believe that the agrotechnical and the reclamation measures used in the long-term context made to obtain large yields of agricultural crops have not fully justified themselves. Since there was an irrational use of the bioenergetic potential, which determined the inconsistencies and difference in the indicator Rn 6, 7, 8, and 9 for mountain zone 2 less than Rn less than 28.96. For the foothill zone, the indicators range from 0.3 less than Rn less than 2, and for the lower land zone of the Kazakhstan, 0 less than Rn less than 0.3. Along with this, the radiation index of the absolute altitude of the terrain Rn with the evaporated on is correlated by dependence. Rn is equal to 0 plus 800 divided by 10 multiplied by n. From the above, it follows that in the formation of humus formation in the arid zone with a range of changes in natural and climatic resources within pH 0.1 till 28.8 kilocal per square centimeter. Beta is 1 to 5%, S index P 0.01 till 0.1%, T index V 2026 multiplied by S0, WD is 30-60%, BB is 2.6 meters per second, OS is 100 to 300 millimeters, and MOR 0.5 to 2 grams per liter, and height is from 1 to 5 meters H. Based on the calculated indicators of natural and climatic data, it follows that the minimum values of the level of humus formation of the soil is MP is equal 0.852%. The maximum values, it corresponds to 2.977%. Changes in the level of humus formations of the soil, depending on the absolute terrain area, are shown in the figure 1. This figure 1, as you can see in the lower part of the slide, shows the relationship between the height of terrain and the humus formation. That means we have here the height of the hand, this one, and we have here the humus formation. There is a same correlation between the first one and the second one. Thus, for many years, when developing a technology for programming crop cultivation based on predictive calculations using empirical formulas, scientists and specialists significantly distorted the calculated data for forecasting the food program, which ultimately affected the gross yield and the sustainability of the agricultural sector in Kazakhstan mainly. Table 2 shows the calculation of the coefficient of use of bioenergetic resources of plants. And this table shows the calculation of the utilization rate of plant bioenergy resources. In the first column, we have the number from 1 to 6. Meteor, for the stations that were considering this paper, we have 6: Suzak, Turkestan, Tukubas, Aris, Shymkent, and Shardala. And for the 4 next columns, we have the calculated bioenergy. Then in the 2 following, we have the biological crop of corn for silo, tons per hectare. And we have, of course, the last one, opportunities for biological damage share. That means we can see the figures from 0.0161 for Suzak, for the second biological crop, 63.2, for who is calculated R, we have 104.4, and biological damage, we have 1.65. For the first region, Suzak. For the Shymkent, for instance, we have 0.127 calculated bioenergy. We have 65.9 for biological crop. We have 217.5 with calculated R, and we have 3.5 for opportunities for biological damage. Then we can now give the main conclusions from this research. First one is the analytical work performed allowed us to determine the relationship between natural indicators and the level of soil humus formation in R, for the rational use of agrotechnical techniques and the prediction of biological yields of agricultural crops. Second one, the proposed methods for calculating humus formation take into account natural resources, reflecting the influence of climate parameters for each region. For the third one, studies have established that within the arid zone of Central Asia and Kazakhstan, in particular in the areas of Southern Aral Sea region, natural and climatic indicators provide an annual cross-section in natural conditions to create from 0.852% to 2.977% of humus. Fourth, in the plains, where the radiation index of absolute altitude R index L knives 0.3 millimeters in order to maintain the process of humidification at a level of 1 to 2% or more, should increase the level of farming systems through the widespread introduction of phytocrops. And finally, rational use and implementation of innovative technologies such as drip irrigation, automation of water use, creates favorable conditions for expanded reproduction of soil fertility and ecological improvement of irrigated sustainability. We would like to acknowledge the Taras State University and Federal University of Rio Preto to help us to develop this paper and, of course, mainly done this research in Kazakhstan. Thank you, and have a nice night.